Welcome back. A couple lectures back we talked about the notions of transposition and substitution, and we talked about some substitution ciphers. In this lecture we're going to talk about some ciphers which basically use transposition. Okay, so what's the idea? Remember, transposition is a cipher in which you take the characters within a text and move them around through some systematic process so that you can recover the original text. So for example, there's something called a columnar transposition, and it's a very simple cipher. All you do is you write down your text in rows, and then you read off the characters in columns. Not a very strong cipher, but one that kids use quite frequently. And then if the message length is not a multiple of the rows, then you just have to pad the last row with characters. Okay, so pretty simple cipher, but fun to play with. But you don't get the idea that transposition is a very weak technique, because transposition is actually used in a lot of very powerful ciphers. For example, we mentioned before the Advanced Encryption Standard, AES, and there's a step in that which uses transposition in a very simple way, right? So AES uses an array of 16 bytes, a 4x4 array, and in one of the steps in each round, it does a simple transposition of shifting the rows. It shifts the first row by no amount, the second row by 1 space, the third row by 2 spaces, and then the fourth row by 3 spaces, right? And so you can see the result there. And that by itself wouldn't be a very strong cipher, but it's used in concert with other steps. Okay, so here's a question for you. If you had a piece of text that you believed was the encryption of a text using a transposition cipher, i.e. only a transposition cipher in this case, how could you increase your confidence that that was the case? Well, you have to think about what it is that a transposition cipher does for you and doesn't do for you, right? So recall that a transposition cipher is all about moving the characters around within a text, but it doesn't change any of the characters. And so however many A's there were in the original text, there's that many A's in the new text, and so on, right? And so if you did a character count on the text, you would expect the frequency of characters in that text, say if it were English, to be approximately the same as the frequencies of letters in English in general, right? And so if you did that kind of a test, you could gain higher assurance that probably it is a transposition. Now notice that if you looked at digrams and trigrams and those kind of things within the text, those probabilities probably would not be preserved, because you might have taken the two characters in a diagram and moved them to different places in the ciphertext. Okay, if it's a columnar transposition, then it's pretty easy to see how you might go about decrypting that. Just hypothesize what the length of a row is, and if that doesn't work, try a little longer row, and so on. So a columnar transposition isn't a very strong cipher. Okay, whatever kind of cipher you have, whether it's a substitution cipher or a transposition cipher, you might come to the decision, well, this isn't very strong. I'm going to take two of these things and I'm going to put them back to back. So I'm going to apply one cipher and then apply another one to the result. And sometimes that's a good thing to do. And that actually is how most modern encryption algorithms work. They apply a number of steps one after another in what are called rounds. But sometimes applying two ciphers back to back not only doesn't make things better, it might make things worse. This is an example of what's called a product cipher or a cascade cipher, where you apply several of them in a row. Think about, for example, the Caesar cipher, right? If you applied one Caesar cipher and then another Caesar cipher, it's not going to make a whole lot of difference. And in particular, if the shift that you use in the first cipher and the shift that you use in the second cipher together add up to the size of the alphabet, say 26, then you're going to get back to the original text. That's probably not what you wanted to do. Okay, so transposition is another important building block in modern ciphers and in ciphers in general. And because it preserves the symbols that are in the text, you can look at a transposition and do some kind of letter frequency analysis on it and verify for yourself that it probably is a transposition cipher that was being used. If you take a number of ciphers and combine them, cascade them, then what you have is called a product cipher or a cascade cipher. And that may be a good thing to do, but it may actually make things worse rather than better. Thanks.